have your push notifications on.
Okay, here we go. Video is working. We are going to learn about vectors today. So vectors are just a line segment that has direction and has magnitude. Magnitude just means length. Okay, so if there's any vocabulary words that you're not familiar with, just let me know, and then I'll tell you what's going on. So vectors are denoted by lowercase boldface letters. Now, I cannot write in boldface, so I just put a little arrow above it like that. So that's a vector U. That's a half arrow because I'm super lazy. Okay? Do some of your teachers do this? Physics teachers, they put like an arrow like that. Does that look familiar? No. No? Yes, yes. Please tell me that this is not foreign to all of you.
It's definitely foreign to me.
Okay, if you've never taken physics, then yeah. But this is just a notation of it. I always use the half one. I'm just kind of used to it. It's like more of the calculus-based ones that I use. So, so since we cannot write boldface, we don't. We're not. You can't write bold. You're not Word. Yeah. That's bold.
Okay, so a pen that gets bigger when you.
You know what? Just write a gosh dang arrow over it, okay? Kind of like this one. Hey, look, this one has exactly what I did. So it's got the little arrow. If you can't really see it here, but I'll zoom in. You can tell there's a little bit of a top to the arrow. There's a little bit of a top to it, so that's how I do it. Okay. So that's called component form. It has the chevrons. I call it chevron form. You know what chevrons are?
No, like this.
That's a chevron.
Oh. Yeah. See, that's not what I was thinking.
That's a chevron.
Chevron?
That's a chevron.
This is chevron. What? Yeah, this is chevron. Oh, she makes sense.
They have a parentheses and a bracket and a chevron. This is a chevron.
A chevron. I would never do that in my life.
All right. Well, you know what? You've seen it now.
Does it mean something else, or does it just look like that?
This is a vector 2, 3 that goes in the horizontal direction 2, the vertical direction 3. So if I'm starting here, I'm going to go over 1, 2, and up 1, 2, 3 with the final point right here, and there's my vector. Okay? This is just an example of it. Okay, that's what a vector is. It just gives us direction and magnitude. So magnitude is just really the distance formula. Okay? So if I use this, I think it's easier to do it like this. So if I want to find the magnitude of this right here, the double bars mean magnitude. It's just going to be 2 squared plus 3 squared. Okay? That's all it is. So if everything's in vector form and not point form, it's much easier because you're not subtracting so much. So usually the first thing I do is get everything into vector form if I'm given a point. So, by the way, this would just be root 13.
What is point form?
Like the initial point, -2, 3. Click on this next example. That's a point. And then you have another terminal point right here. Okay, and I'll talk about that a little more in just a second. I know I'm throwing out a lot of vocabulary at you, especially if you didn't take physics. Okay. We'll get you there. Okay. So let's actually do an example of some sort what a vector is. So find the component form, which means the chevrons. I want to find the chevrons in magnitude of the vector v that has initial point -2, 3. So we can just plot this for giggles. In terminal point -7, 9, which is going to be right here. Okay? And make sure that you draw your arrow at the end, at the terminal point. So if you notice, this has an initial point, which means your starting point. And your terminal point is your end. This is also known as the tail, and this is also known as the head. So this is the tail, this is the head. Tail, head. Okay, yeah, so a dog's tail is looks like that. It's straight. I don't know, curve, whatever. It's just a line of some sorts.
Imagine if dog tails were straight. Like, it's like a wiggle like
Some dogs do have straight tails. This is also known as the head. Okay, so whenever we want to find the actual vector itself, so vector v is going to be equal to, it's always going to be the head minus the tail, or the end minus the start, or the terminal minus the initial. Okay, so it's the head, so it's minus -2. So that's for the horizontal, so -7 minus -2, and then we're going to do 9 minus 3. So what is -7 minus -2? -5, comma 6. So this is my vector v. Much my bar. Okay. So this is the vector, and to find the magnitude of the vector, it's just the square root of each component squared. So even though it's negative, it gets squared, which is going to make it positive. So I'm going to get plus, which is 61. What's that? Okay, so all we're doing right now is I'm giving you 2 points. Find the vector from the 2 points. That's it. So it's why we just did the head minus the tail for the x portion. We call that the horizontal portion, and for the y portion, that's the vertical portion. So that's where you get this vector right here. And then to find the magnitude, you just square each component inside of there, add them up, square root it, and done deal. All right. Okay, so we're practicing this again. Right up here, it just says 2 vectors that have the same magnitude and direction are equal. They might start in a different spot, but they are equal. Okay? So let U be represented by the directed line segment, so P to Q. So which one's the ending one right here if it's P to Q? So Q is the end. P is the start. So what is that vector U before I even read on to V? So if it's from P to Q, which is vector U, how do I find vector U? Subtract what?
3 minus 0 and 1 minus 0, which is 3 and 1.
Okay. We good? And let's do vector V now. So again, the end here is S, start here is R, so it's going to be 5 minus 2, and 3 minus 2, which is 3. So those are the same. I don't even need to find the magnitude there. I don't have to. I mean, well, because you can just look at it and just see, oh, these are exactly the same thing. Are they not? Hey, what is the magnitude of U if I asked you that?
9 plus 10,
root 10. What is the magnitude of V if I asked you that? Yeah, root 10, same thing. Okay. Here, did you want to draw these to look at them, or we're good?
No, I think you're good.
We're good?
Yeah.
No drawing? Okay, so we can add vectors, subtract vectors. You don't multiply them, but that's about it. You just add and subtract them. So this is what it kind of looks like. So if we had to draw u plus v, all we're going to do is we first draw u, and then starting at the head of u, we start drawing the tail of v. Okay? So I'm going to go ahead and demonstrate this for you. So I'm going to first draw u. So I'm going to draw u right over here. Okay? There's u. Now from here, at the head, I'm going to draw v. Look at v right down here. V is about how long? About an inch, going in which direction? So guess what we're going to do from the head here of u? We're going to go an inch to the left, give or take. So now from the start to the finish, I'm going to draw a little bit of a dotted line. Who remembers what I called this from a couple classes ago? Yeah, this is the resultant, which is going to be u plus v. So if you just add the two vectors, you're going to get this resultant vector right here. Okay? And it works with more than just adding. You can like multiply like a 2 in front of that, give it we called it a scalar because it's just a number. We don't call it a coefficient, but we call it a scalar. You can do the same thing. You just draw a u twice as long. Okay? And then they're just talking about here with negatives. So you can also draw v in the negative direction. Like if I was subtracting, then it would just go in the opposite direction. That's it. So, hey, for giggles, let's draw u minus v. Okay? So the only thing that's going to change is the direction. The length will not change. So if I'm going to draw u minus v, I'm still going to draw u. And now instead of going from an inch to the left, inch to the right. This is u minus v. Okay, now we rarely draw this stuff. I'm drawing it just so you can kind of see it. And we're going to get into some algebraic stuff. Okay. Flipping it over. We just talked about number 3, drawing, just subtracting these guys. So, how would you? Okay, on this one? Fine, let's look at 3, digest it a little bit. So, we start with the v. V is positive, so we're going to draw v.
Oh, wait, never mind. I wasn't looking at that.
It's fine.
I was looking at the v one.
Well, we're starting with v, though. So, v goes this way, and then w, instead of going up and to the right, down and to the left. Complete opposite direction. So, this would be v minus w. Now let's work on adding these. Okay? So if I have 1, 2, and v is 3, 1, this just wants to add u plus v. So you just do the horizontal, add those together, which by the way you would think as the x's. And then you would just take the y's, which is known as the vertical, and add those together. So what is u plus v? 4, 3. Very good. What about 5? Now it's u minus v. Say that one more time. No, so we're taking u. You're correct the first time. We're taking u first, subtract it by 3, and then take 2, subtract it by 1. Got it. Hannah. One of you. Okay, so for number 6, now this number in front of it, we call that a scalar. It's going to multiply it. So I'm going to first multiply everything in u by 2. So what happens now? U becomes 2, 4, minus, multiply everything in v by 3. 9, 3. Let's subtract those. What is 2 minus 9?
7.
Kind of 7.
Negative 7.
And then 4 minus 3 is?
1. Oh my god.
Any questions on how to add or subtract vectors? Okay. This is a really dumb question. 2 players kick a soccer ball at exactly the same moment. Okay, like that ever happens. One player's foot exerts a force of 66 newtons north. The other player's exerts a force of 88, that's newtons, not north by the way, 88 newtons east. We want to know the magnitude and the direction of the resulting force upon the ball. Let's draw a picture. So here are the 2 soccer balls. They're just both located at this dot. Stupid question, alright? They kick one of them 66 newtons north. Okay.
How does that work? I thought you always had to draw the second one from the center.
Yeah, let's just draw from, so we usually do want to draw it from here, because it's going to give us the same resultant. Alright, that's all I really care about. Or it doesn't matter. Or we can draw it from here. Not going to matter. Let's just draw it from here. Okay, so, and then from here we have our next force, which is 88. This is a really stupid question because it's hard for you to understand, because it's really stupid. This is 66, this is 88. Which makes a resultant force of that right there. Well, I mean, this is the vector 88, 66, technically, right? But it's not asking for the vector, just asking for the magnitude. So which is this the distance? So how do we find the distance of that right there? So magnitude is going to be the square root of, I'm going to do 88 first because I do the horizontal first usually. 88 squared plus 66 squared. So it actually is a nice number. And we want to take a gander at the nice number is 110. And now the direction. I like it. We already know it's going to be north something east. Okay? Because I'm trying to solve it from here. So how do I find that angle? Magic. It's a right triangle, right? So we're going to use tangent. So tangent, what do you want to call this? A? Sure. Tangent of A is equal to 88 over 66. So second tan, 88 over 66 in your calculator gives me an answer of 3 mode, please. 53.13. Any more decimals after that?
0.
Oh, it's 0, so let's keep it like this. Okay, so my direction would be north. I didn't leave myself enough room here. 53.13 degrees east. Oh. All right, woo, that's a good question from almost 30 years ago here. In the 1992 Winter Olympics, about 10 years before any of you were born, is that correct? About 10 years, give or take. Give or take. You were born during the Winter Olympics? Oh. Okay, so, in the 1992 Winter Olympic trials, Herschel Walker pushed the USA 1 bobsled with a force of 110 newtons at an angle of 42 degrees with the horizontal. Find the horizontal and vertical components of the force. So there is actually a formula for this, or you can just draw a picture. Just draw a picture. Okay, so this guy right here is pushing up a bobsled. Like this. Okay? And with the ground, it makes an angle of 42 degrees. Okay? So this is 110, and this is a right triangle. So I need to find the horizontal and the vertical component. So let's just call this x and that y. X is our horizontal component. So how do I solve for x?
Cosine. Yeah.
I like it. So cosine of
42.
Equals?
X over.
So essentially x equals 110 times cosine of 42. Do you agree? You want to use your calculator or want me just to tell you? Alright. 81.745. I didn't give myself enough room here. That should be in newtons. Newtons. I didn't write really well. It's there. There's the newtons. And then to find the y value, you're going to do... I like it. Sine of y over 110. So y is equal to 110 times sine of, which equals, pretend you do it in your calculator, and there, 73.604 newtons. Okay, so here's the formula for the horizontal and vertical components. X is equal to whatever the force is times, cosine of theta. This is your formula. Okay, whatever your force is times cosine theta, and y is going to be your force times your sine theta. This will always be your formula for your horizontal and vertical components. So you can always draw a picture and do it this way, or you just like, nah, I'll just do it this way. Your call. Uh, 9 and 10 are the same problems. I don't care which one you want to do.
Neither.
Okay, I'm fine with that. Neither?
Do they have anything different than anything else?
It's law of cosines.
Yeah.
Okay, we
Let's do 9.
9?
There's less words.
Believe it or not, I don't even have the answer for 9, so that means you'd have to use a calculator. I don't know why, but I have the answer for 10. I don't know, 10's harder, but... So, let's make a scale drawing showing a force of 20 newtons pulling an object east, another force of 10 newtons pulling the object of the compass direction of 150 degrees. That should be a heading. That's stupid. In a, we'll say a heading direction. It should say heading. Draw the resultant force vector and use your drawing to find the magnitude and the direction of the resultant. So here we go. Let's do it. So we're going to draw this. So the first thing we're doing here is we're pulling this, just an object this way for 20. And then 150, which means what quadrant am I going in? So it's a heading.
1, 2, 34.
One of those, yes. Which one is it? 4, because we start here and go down 150 degrees, so it's going to be 4. So, and this is going to be for how long? 10? So not as long. Don't have to draw it as long. Okay? And then, so here's a resultant. So this is what happened. Could have just taken this shortcut the whole time. So what's this angle right here then?
It's 180 minus
It's 120.
30 plus 9.
Oh, yeah.
Yeah, this is 90 right here, and since this is 150 right here, there's only 30 degrees left to get to there, so it's going to be a total of 120. Okay, so, let's do it. How do I do it? What do you do? C squared equals
A squared plus B squared minus 2AB sine.
cosine. Okay. So this gives you an answer of... Okay, fine, I'll just tell you what it is. So, I want a little bit of a secret. I don't know if it's a secret, but it was embarrassing at the time, I'll just tell you. So when I made the other video notes, I was just like by myself, and I was just copying off like the answers to the notes. And one of the problems, because I'm a little dyslexic, I switched some of the numbers around, wondering, what if I was going to notice?
Yeah. That was one of them. Yeah.
There was one of them where like I was like, I'm just moving on. I don't have time to fix it. So one of them, I was a little dyslexic. I looked at the key and I switched through the numbers around.
Are you actually dyslexic?
Yes. Self-diagnosed.
You know that video of Bella Thorne where she's like, I got over my dyslexia? Yeah. And she was like, the letters float on the page. Do they actually?
Okay, so now we want to find the direction. So the direction's always from the starting point. So I want to find that angle right there. So how do I find that angle? This angle right here.
What did you say?
How do I find this angle right here? Because that's my direction.
Law of sine.
Law of sines. What is my law of sines?
Sine
So sine of which is 120.
over 26.4, the whole number,
I put dot dot dot, which means the whole number.
equals
Equals. We'll call this A.
sine of A over
All right, and you want me to tell you the answer? Okay, so you're going to get 19.107. If it gives you a question with headings, you need to answer in headings. If it gives it with you in bearings, you need to do it in bearings. If it gives it to you with in the direction with the x-axis, you need to do it that way, which is the unit circle. Okay. So what would the heading be? If that's 19, what's the total heading?
109.
How'd you get that?
I added
Yeah, because we really got to start up here for a heading. So 90 plus that angle, which is
109.5.
okay. I do just want to go this one right here because we haven't talked about the positive x-axis, but yet we have our entire trig career here. That just means unit circle.
Wait, hold on. Oh. What means
So if you ever see the positive x-axis, because think about it, when we start drawing with the positive x-axis, that's 0. Isn't that the unit circle?
Yeah.
So if I had to draw 30 degrees, it would be right here. That's 30 degrees. But right, and this would be negative 45 degrees. Just giving you a heads up in case you see it. Okay, I feel like we've done everything. Like, the rest of these are just all repeating itself. I don't know, maybe the wind one? I don't know. I can do the wind one. That's usually a commonly asked question with winds and airplanes. Yes or no, or I can move on to the next sheet.
Wait, what did you
Number 12, I'll just do 12. It's a quick one. It's pretty common. Okay, so you have an airplane that's flying due east 100 miles or meters per second? I don't know which one that is. I would say meters. Wow, that'd be pretty good if it was miles. That would be pretty good. Velocity isn't always in meters, but I guess you said it is. So this is 100, and then the wind is blowing out of the north. It's blowing out of the north. What direction am I going in? If I'm out of the north? South. So it's blowing from here, from the north. So the resulting velocity, so that plane is actually has a higher velocity since the wind is blowing in a direction, or if it's blowing against it, it could be a smaller velocity.
It's a right triangle.
So it's a right triangle, which is really nice. So all we're going to do here is square root of, yeah, we're going to do math. Which I'll just tell you is 100.124. Okay, hey, the next sheet, like I said, this is going to be real quick. So go on the next sheet, it's real quick. So we already talked about most of this stuff up here. So this is component form, also known as chevron form. So we just talked about that, going from one point to another. We just use it with chevron A, comma B, and chevron. All right. There's also an I and J form. Just be aware of that. Okay. So for example, if I have 1, 3. I is always in the horizontal direction. J is always in the vertical direction. So which number is in the horizontal direction here? I. So it's 1 times I. Plus, and the B one is I'm changing from component form to I and J form. Because sometimes they ask you the questions in I and J form, so you just have to be aware of it. Okay, so what's 1 times I? 1I. Just I plus 3J. So it's going from component form to I and J form. They do this because in physics, the I direction is always the horizontal. So sometimes they just say, hey, in the direction of the I vector. Like, oh, okay. That's right. Or in the direction of the J direction. Oh, that's up. It's negative, it's down. Try this one on your own. What if I did 2, negative 3? What would that be in the I and J? I heard it. One more time. If you notice, I put little arrows over I and J because they are vectors. It's actually the unit vector. This is the unit vector to the right. What's a unit vector? We'll learn that in a little bit. So if you had to draw this vector right here, this just means, let's put this in component form, because every time I ever teach this, I taught a whole class about this stuff, everyone just like, can we just put it in chevron form? And I was like, sure. So what is this in chevron form? Negative 6, 2. Okay, so how do I draw this? 1, 2, 3, 4, 5, 6. 1, 2. So it looks like this. Yeah, so I would just start at 0. They don't give you a starting point. So what's the length of that? Negative 6 squared. What's going to happen to the negative when I square it?
40. Root 40.
Very good, it goes away, so we get root 40. Okay, number 2, it's just we're writing this out in that form. So we did this before, doing it in component form, which is chevron form. And now we're going to do this in I and J form, which is also known as the horizontal vertical components. So we have initial point M, ending point N. So let's find the horizontal and the vertical components. So in the I direction, I'm doing what minus what? Ending at 2. So we got 2 minus negative 1, which is 3. And in the J direction, that's the Y's. So it'd be 1 minus. Why is it 1 minus 5 and not 5 minus 1? It's always the end minus the beginning. So this is negative 4. So to write this out now, I would write it as you just put minus 4. Okay, so again, everything we're doing here on this sheet has just been new in terms of notation. That's it. We haven't really learned anything new other than just notation. And I think there's just a vocabulary word I go in the back, and that's about it. Okay, we good?
What?
Remember that formula I did with you where it was x equals force times sine theta, y equals force times cosine theta?
Yeah.
That's all this is.
Okay,
So in this case, for x, the force is 7 root 2 times sine of 5 pi over 4. So what is that? I think it's 7. I think it's 7. I think it's 7. Because sine of, maybe it's negative 7. Sine of 5 pi over 4 is, that's negative root 2 over 2, so it should be negative 7. So it's negative root 2 over 2 times 7 root 2. So the root 2's go away, essentially. Well, the root 2 times root 2 is 2 divided by 2, which is 1. So in the y direction, it's going to be 7 root 2 times cosine of 5 pi over 4, which is conveniently also negative.
Whenever you do that, did you calculate your speed?
For this one, yeah, this has to be in radian mode, because we're asking the thetas and pi's. Or you could just know your unit circle and, figure it out.
I could, but no, why would I do that?
Okay, so this is vector W in I plus J form would be.
Negative 7i.
Yep.
Minus 7j.
Okay, and then the last little tiny thing here. I know, we're kind of going right to the bell. Like I said, we're missing Wednesday, so I'm just trying to do a little bit of catch-up. We good here? That's the last thing. It's just a little formula. A unit vector. A unit vector just has a magnitude of 1. That's all it is. So a unit vector is a magnitude of 1. So it's going to have the same direction, but just a magnitude of 1. So this is your formula. You take your vector. So the unit vector is the vector divided by the magnitude. Okay? So you just take the vector, divide it by the magnitude. So for instance, they want a unit vector having the same direction as v. So I need to find the magnitude and then divide each of those by the magnitude. So what is the magnitude of v here? So 2 squared plus root 5 squared, which is root 9, which is, so the unit vector is just going to be, just divide these by 3. So it's going to be 2 over 3 plus, you're just dividing everything by 3. That's it. Because if you were to find the magnitude of this, you'd get 1.